All right, so 8.1 is called Law of Sines. So 8.1 is Law of Sines, 8.2 is Law of Cosines. You're going to learn both these methods, and both of these methods are used to solve triangles when they are not right triangles. So if you think about right triangles, we use SOHCAHTOA to solve, right? If we wanted to find a side length or an angle, we would use SOHCAHTOA. These are not right triangles, so you cannot use SOHCAHTOA. There would not be a hypotenuse, okay? So you can't use SOHCAHTOA, so you use a method called Law of Sines or Law of Cosines. Law of Sines is used to solve, so non-right triangles are also called oblique. So when you see the word oblique, it just means that they're a triangle that's not a right triangle, okay? You will use Law of Sines when you are given specific information, and then you'll use Law of Cosines when you're given specific information. Law of Sines is used when you are given two angles and the non-included side, which would be like C, A, and then side C. So two angles and then non-included side. The included side would be between them. So if you were given those two pieces of information, you'll solve the triangle using Law of Sines. If you were given angle, side, angle, so two angles and the included side, like angle C, angle A, and side B, then you can also use Law of Sines. And the last one is side, side, angle, which has a special case. When we get there, you'll know it, which would be two sides and the non-included angle. So like side B, side C, and then angle B, the angle where they don't meet. That would be the included angle. So that would be if you're given side, side, angle. So any of those three cases, and you would set up your Law of Sines. So Law of Sines is any two of these three set equal to each other. So it's the side over the sine of the angle equals the side over the sine of the angle equals the side over the side of the angle. The letters match. So if it's side A, we use angle A. If it's side B, we use angle B. And if it's side C, we use angle C. You can also flip this, and it still works. Like I could make this sine of A over A equals sine of B over B, and it still works as long as you flip both sides, okay? We tend to do the side over it just to be consistent. I'll follow that pattern, but it doesn't matter as long as you flip one and flip the other. So then we'll set up a proportion. You will know three of those four things, and then you will cross multiply and divide. That's it. So if you can plug into a formula, you can do Law of Sines. Plug in, cross multiply, divide. These will all be in degrees, which means your calculator needs to be in degrees now. So if you've like not touched it, I mean, if you did it for the pre-ACT, maybe you switched it, but the last time we used them in here, we used them in radians. So you just want to make sure they're in degrees. Yeah. All right, so example 1 says solve the triangle given C is 102 degrees, B is 29 degrees, and side B is 28 feet. Round your answers to the nearest hundredth. So first of all, the word solve the triangle mean find all the missing angles. And all the missing sides. So if you want, you could draw yourself a triangle. You don't have to, but it's good practice to draw yourself a triangle. Label it A, B, C in any order you want, but the capital letters are your angles. Sides A, B, C are opposite the angle names. And then I would go back and fill in the information that they gave me. So they gave me angle C is 102 degrees. Angle B is 29 degrees. And side B is 28 feet. Which means I need to find angle A, I need to find side A, and I need to find side C. So if you're given two angles, how do I find a third? Add them and subtract them from 180. So that's the easiest thing to do. If you're given both angles, go ahead and do 180 minus the 28 minus, or sorry, not 28, sorry, 29 minus the 102. 180 minus 29 minus 102, and I get 49 degrees. Now I have all three angles. Now I've got to find the missing side. So in order to do law of sines, you need one complete ratio. I need both the angle and the side with the same letter. So if you look at what's initially given to you, you already have it in B. I have angle B and I have side B. So I am always going to use B as one of my ratios. So I'm going to say side B over the sine of B equals, and I'm going to say C over the sine of C. And then I'm going to say side B over the sine of B equals A over the sine of A. So we're going to do it twice. And both times we're using B because that's the information that was given. After we found angle A, we also have, I could find, no, that's still the only complete ratio. Sometimes you have two complete ratios once you find angle A, but because that's information we found, I would always stick with what was originally given to you. So again, because we had both B's, that's what I'm using. So I'm going to say side B, which is 28, over sine of 29, equals side C, that's what I don't know, over the sine of angle C, which is 102. And then I'm going to cross multiply. 28 times the sine of 102 equals C times the sine of 29. And then I'm going to divide both sides by the sine of 29, so C is by itself. And then I'm going to type this whole thing in my calculator all at once. You don't have to. You could separate it out, but it's easy to do it. Just be careful and make sure, because when you hit sine, the parentheses are going to open here. Make sure you close them again before you hit your divided by symbol. So 28 sine 102, close your parentheses, divided by sine 29. And I get C is, it says round to the nearest 100th, sorry, 56.49. And then I'm going to do the same, and this is technically feet. If it asked for a unit, it would be feet. And then I'm going to do the same thing for A. So B, which is 28, over the sine of 29 would equal A, which is a side I don't know, over the sine of angle A, which we found to be 49. And then I cross multiply. And divide. So A equals 28 sine 49, close the parentheses, divided by sine 29. And I get A is 43.59 once it's rounded. And again, if it asks for the unit, it would be feet. All right, so again, I wrote it out. The angle A is given, angle B is given, side C is given. So this time I can't even start it with the law of sines until I find angle C, because I don't have that completed ratio, okay? But I can find angle C by doing 180 minus the other two. So 180 minus 43 minus 98, and I get 39 degrees. So now I have no choice but to use what I found, like other than last time we're going to have, like sometimes you're going to get given that full ratio. I had to find that first. So sometimes you're going to have to. So if I wanted to find A, now I'm using C over sine of E each time. So C over sine of C equals A over sine of A. And C over sine of C equals B over sine of B. So C is 22 over the sine of 39 equals A over the sine of 43. Cross multiply. And divide. So side A is 23.84. And then C, 22 over the sine of 39 equals B over the sine of 98. Cross multiply. And divide. Mm-hmm. No, like as long as you give me the setup, I mean, you're going to start to cross multiply and divide. It's not a right triangle, so you can't use Pythagorean theorem. Yeah, I'm glad you asked that. You have to set up the other side. But you just don't have to give me like every single step because it's going to be cross multiply and divide every single time. So 34.62.
Can you explain again how do you get like the C over sine C equals A?
So, they are C over sine C equals A over sine A equals B over sine B. Like, you can pick from those, right? You're going to take two at a time. I find the one that has both the angle and the side. And that's the one you're always going to set equal to the other two. So, when we started, we had this. We didn't actually have C, right? We didn't have this one yet. From the start, you didn't have the angle and the side opposite it of any of them. The last one we did. And we grabbed that and we set those every time.
So, like, if the 22 was like between the A and the C, the angle you would use instead of C is B?
So if the 22 was between the A and the C, you said, over here, then I would use B. Yep, so you have the full ratio of the B's. Yep, whichever one you have both of. And it might take one step to get both, like this one. If you get the other two angles, you have to take one step to get both. But before you can use law of sines or cosines, you're going to have one complete. Questions so far?
Is there ever going to be one?
All right, so here's the not fun part about law of sines. Law of sines is a much easier formula than law of cosines. Like law of cosines, the formula is a lot. But law of cosines, or law of sines, which is what we're doing, has something called an ambiguous case. An ambiguous case is a second triangle that can be formed with the same measurements. So this can only happen, and it doesn't always happen, but it can happen when you are given two sides in the non-included angle. So if your letters spell a bad word, forwards or backwards, okay, look at it backwards. You see it there? Yes, okay. This is when you can have an ambiguous case, okay? And like if you go back to geometry and you remember the ways to prove triangles were congruent, we had side, 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 angle, side, angle, 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 side, hypotenuse, leg. That was not one of them. And it's not because it's a bad word, okay? It's literally because with that information, you can make more than one triangle. So it is possible when you're given that information for there to be a special case that is no solution, like you literally cannot, like if I give you this side length and if I give you that side length and this angle, it actually doesn't touch. You could never make a triangle. That's a no solution. Or you could have one in which two triangles are possible given the same measurements. So if I zoom in on this, like if I gave you B, whatever the length B was, and then I gave you side A, whatever the length side A is, and I gave you angle A, so this has to be the same. I can either make a triangle that way, or I can swing A out over here. It does not change the angle at the bottom, which is what's given. It does not change B, but it makes an entirely second triangle. So this ambiguous case has three outcomes. One is it has one triangle like you already are used to. Two, it has no triangle, which would be a no solution. Three, it has two triangles in which you'd have to complete both triangles. So you're going to end up with 6 parts to your answer. The missing parts for triangle 1, the missing parts for triangle 2. So that's the catch about law of sines. And again, it only happens if the information given is two sides and the non-included angle. So how do we solve these problems? We assume, so we're going to start to solve it just like we did before. We're going to use the law of sines to find the first missing angle. So you'll have 2 missing angles. We're going to use law of sines to find the first missing angle. And we're going to call this like whatever letter it is. If it's A, B, C, we're going to say it's that one. And that is our first triangle, first angle in the first triangle. And we are going to assume there is another triangle. And the way you start the second triangle off is by taking what you found that first time and subtracting it from 180. So if what I find the first time is angle B, I'm going to label it B1 and give it its value. And then I literally like draw a line and make a second space for a triangle. And I start B2 by doing 180 minus B1. All the information that was given to you at the beginning is true for both triangles, but now we've got this second angle that is a different measurement. Then we finish out both triangles. The first triangle, if you get to that part, will always finish. Okay? If it's no solution, you will get it from step 1. If you get past step 1, then you will always be able to finish out triangle 1. When you go to finish out triangle 2, we're going to assume there's a second triangle until you go to solve for the last angle. And when you do that, either you can get an answer, your calculator's going to spit out an answer and you know it's a second triangle, or when you get to the second angle that's missing in the second chart, so the third angle, it will say it's undefined, and then you know to eliminate the second triangle, or it's negative. We will eliminate the second triangle, and you will assume there's only one. This is the most confusing part of law of sines and law of cosines. Like, if you can get through this, you're good, okay? So we're going to walk through it. But those are the steps. So, like, if you get totally confused later, those are the steps. So, first thing I'm going to do is draw out what I've got. A, B, C. Side A is 22. Side B is 12. And angle A is 42. Hey. All right, so look at what you've got, right? You've got two sides given. That's the first indication. You have two S's, two sides, and the angle that's not between those two sides. So if it's two sides, then it's the angle between. If I had 12, 22, and where they meet, then there's no possible ambiguous case. It's only because it is this side, and the non-included angle, which really could be A or B. But it's the one where they don't meet. So that's where you want to, like, asterisk, ambiguous case. This one stinks. This is not going to be fun, okay? But that's when you need to notice it. Two sides and not the angle where they meet, but another angle. So now I'm going to start to solve it. I cannot find the angle, like, by subtracting from 180 because I only have one angle, right? But I do have a complete ratio, which is which letter? A. So I have side A and I have angle A. So I'm going to use that with B over sine of B. And hopefully get to use it with C and sine of C. So I'm going to start with B because B is the one I at least have the side of. So I'm going to do A, which is 22, over the sine of angle A, which is 42, equals side B, which is 12, over the sine of angle B, which is what I don't know. Then I cross multiply. 22 times the sine of B equals 12 times the sine of 42. And then I divide. So this is the first time we're using the formula to solve for an angle, and it should look a little different. On the last ones we did, we had a side like B, lowercase b, equals that whole thing. And so we just typed in the calculator and that was it. But now we're saying that's not angle B that equals that. It's the sine of angle B. So I'm going to plug that in the calculator. I'm going to do 12 divided by, 12 times sine 42, close the parentheses, divided by 22. And this gives me like 0.36498, so on and so forth. But that's the sine of B. How would I get the angle B? To the -1. So I'm going to do negative sine -1 of what I get from that answer. So I want to keep it exact. So second sine, second answer. And I get angle B is 21 point, does it say 100th again? Yep, 21.41 degrees. So when you're looking for an angle, there's going to be one extra step, which is do the inverse button.
And you need to have the whole number.
Yeah, you want to keep it. So you could actually do it from here. I could do sine -1, that whole thing. And it will give it to you in one step. So if this was a no solution, I would not have an answer now. You would see it there. You would get an error. You'd get sine of something is something bigger than 1. And then it doesn't work. So the fact that I have an angle already tells me this is either a 1 triangle scenario or a 2 triangle scenario. So I have B, and I'm going to call it B1, 21.41. Which means I've got to solve for side C1 and angle C1. Those are the other two things I'm missing. Before I do that, though, I'm going to remind myself to test for the second triangle. So I'm going to call it B2. To find B2, we're going to do 180 minus 21.41. So whatever you get from the first angle, not what's given to you, but what you find, you're going to subtract from 180. You're going to find the supplement to that. And that is the second angle in the second triangle, because that first angle goes to both.
But wouldn't that be C?
No, you're finding the supplement to B, but you keep it as B. So it's two separate triangles.
So the C.
We're going to find it. So we got to find it for both. We got to find C1 and we got to find C2.
So wouldn't it just be the opposite?
No, because it's 180 minus what you're given minus B1. And then it's 180 minus what you're given minus B2. So for the first one, like I go back to the first one and I continue to complete triangle 1. So in triangle 1, I know A, I know angle A, I know B, I found B1. So I'm missing angle C1, which is the third angle in the first triangle. So I'm going to do 180 minus the 42, which was given, minus the 21.41 that I found. And that's 116.59 degrees. So now all that's left in that first triangle, so now I found this one, 116.59. And we found B1, 21.41. Now all that's left from that first triangle is side C1. I still want to use the information I was given originally, which is the A's. So I want to use 22, which is this, A over sine of A. 22 over the sine of 42 equals C1, which is side C1, over the sine of angle C1, which we just found to be 116.59. And then we cross multiply. And then we divide. So side C1 is equal to 22 times the sine of 116.59 divided by the sine of 42. And I get side C1 is 20.40, which would be this last side. So I completed the triangle for triangle 1. Yeah. Like an iPad charger? Yeah. Then I have to complete triangle 2. So for triangle 2, and I'm going to draw it out again so we can see that they're different triangles. For triangle 2, I am keeping all the information they originally gave me because that's true for both triangles. So side A is still 22, side B is still 12, and angle A is still 42 degrees. That information is true for both triangles. But then the B we found for our second triangle is 158.59. We found that by doing 180 minus the first angle we found in the first one. So 180 minus the B1. So I've got angle B2. I'm going to just write it bigger. 158.59. I am missing angle C2, and I am missing side C2. Now, this next step is how I know whether or not there's a second triangle. I'm still not sure. The way you find out is when I go to find the third angle in the second triangle. I'm going to have to do 180 minus angle A, which is the one they give me, that's 42, minus B2, 158.59. If what I get from that is positive, then there's a second triangle and I continue. If what I get from that is negative, it's not possible to make the second triangle. So 42 plus 158 is going to be bigger than 180. So I know this is going to be negative. But if you don't know it, just from looking at it, subtract it. 180 minus 42 minus 158.59. And I get negative 20.59. If this angle is negative, I rule out the second triangle, and I know to only keep the first triangle. Yeah. So I know to test for it based on the information that I'm given, the type of information I'm given. So when you are given two sides and the non-included angle. So if you draw out your triangle and you have two sides, first of all, if you have two angles, don't even worry about it. Just keep going. But if you have two sides, then you got to look, is the angle that you're given in between those two sides or where they meet? Then you're still fine. Or is it one of the other two angles where it's not where they meet? Now you have an ambiguous case. So with that, you're going to solve, and you're going to assume there's a second triangle, literally until you get to the last angle of the second triangle. If the last angle is positive, then you're solving both triangles because there's two of them. If that last angle is negative, then you know there's only one. You mean B2? So A is true for both, like A was given. So A is good for both. All the stuff that's given here is true for both. The first angle you find is your whatever one. So like if you find B first, it's B1. If you found C first, it's C1. Whatever one you find first, you label 1. Then you start a second triangle with the same letter, but 2. And to find that angle, you do 180 minus what you found. And that's the first angle. So we did it with B. That was B1. Then when you go find the third angle, if it's negative, you're done. There's not a second triangle. If it's positive, you keep going. There is. Yeah.
So if it's positive, you do the 180 minus C1, and that equals C2?
No. When you go to find C2, you already have A, which was true for both triangles, and B2. So you do 180 minus what they gave you at the beginning, minus what you found for your B2. So to find the last angle, you should be subtracting 2 things from 180.
Wouldn't you subtract C1?
No. C1 is your first triangle.
You don't.
You're done with that. So the only the first one that you find do you subtract from 180, and that's how you make your second triangle. We're going to do it again. Yeah.
What does it mean then in the slide, like the before? It says like no triangle.
So you would get that here. If I go to find the very first angle and it says sine of angle whatever is 1.5, sine can't be bigger than 1, right?
So it's possible for it to be.
And that would be no solution. So there's 3 outcomes here. No solution, 1 triangle, 2 triangles. Yeah. All right. I don't remember which one this is. It doesn't matter. You're going to have to finish them anytime. Just don't forget. All right, so this one, given A is 15 feet. B is 25 feet, and angle A is 85 degrees. So I'm given 2 sides and the non-included angle, which means I'm going to remind myself that it's possible to have the ambiguous case. So again, I have a complete ratio with A, right? And I only have one part of B. So the first thing I'm going to find is angle B. We're going to call it B1. Then we're going to find angle C1. And then we're going to find side C1. So I would do A, which is 15, over the sine of A, which is 85, equals B, which is 25, over the sine of angle B, 1. Cross multiply, 15 times the side of B1 equals 25 times the sine of 85. And divide both sides by 15. And I get 25 sine of 85 divided by 15. And I get sine of B1 equals 1.66. If you catch it, hopefully you do, you remember that sine cannot be bigger than 1, so this is no solution. If you don't catch it, then the next step you're going to do is sine negative 1 of 1.66, and your calculator is going to tell you it's no solution. It actually says like error domain, right? 1.66. I think the words are error domain. So this is a no solution triangle. On WebAssign, you put the word impossible in the box, in all the boxes. Copy, paste, copy, paste. So nothing exists. You literally can't connect the lines. Like if I gave you a piece of paper or a string that was 15 centimeters long, 25 centimeters long, and I told you that they have to meet where angle A would be 85 degrees, you could not find another side that would connect them. Yeah. Sine -1 of 1.66? Yeah, remember this is the sine, so you're looking for the angle. All right, so we did a 1 triangle. We did a no triangle. What do you think this is going to be? A 2 triangle. All right, angle A, B, C. So side A is 12, side B is 31, and angle A is 20.5. So I've got to find angle B1, angle C1, side C1. God bless you. So my complete ratio is, again, the A's. So 12 over the sine of 20.5 equals 31 over the sine of B. We're going to call it B1. Cross multiply. And divide. So I get the sine of B1 equals, and I type that whole thing in. So 31 sine of 20.5 divided by 12. This is like 0.9047, so on and so forth. I second sine that. And I get angle B1 is 64.78 degrees. So now I know at least it's not a no solution. Immediately, I'm going to come over here and say B2 so that I remind myself that there's a possible second triangle. To find B2, I'm going to do 180 minus 64.78.
Wait, what's the 0.9047?
That's what you get if you do 31 times the sine of 20.5 over 12. So this whole, like if you type that in the calculator, it's that 0.904, so on. So 180 minus what I got for B1 is B2, which is 115.22. So you can solve out triangle 2, go back to triangle 1. It doesn't matter in which order you do that, okay? Or you can go back to triangle 1, finish it, and then come back to triangle 2. So we'll do that, but you could do this in either order. So now the last thing I have to find in my first triangle is angle C1. It's the third angle, so C1 equals 180 minus A, because that's what's given, minus B1, which is 64.78. So angle C1 is 94.72 degrees. And then the last thing I have to find from triangle 1 is side C1. So I do 12 over the sine of 20.5 equals C1 over the sine of 94.72. Cross multiply. And then divide. So C1 is 34.15. So now I'm done with triangle 1. If you want to redraw out triangle 2, you totally can with the original information that's given to you, because that's true for both. So this is 20.5 degrees. Side A is 12. Side B is 31. And then we found angle B2, so these would be 2's, which is 115.22. Now I've got to find angle C2, which is 180, minus the A that was originally given, minus the B that we found, which is 115.22. So 180 minus 20.5 minus 115.22, which this time is positive. So now I know there is a second triangle. And then you just have to find the last part of the second triangle, which is side C2. So I still use A because that's my complete ratio and that's what was given to me, so it's the safest. 12 over the sine of 20.5 equals, I'm looking for C2, so side C2 over the sine of angle C2, 44.28. Cross multiply. And divide. Sine 44.28 divided by sine 20.5. C2 is 23.92. So the last thing, and like I said, this is the easy part, is the area of an oblique triangle. So what happens, what we know to find area of a triangle is 1/2 base times height, right? That's like the old school area. And then in geometry you learned if it's an equilateral triangle. Those are the two formulas you know. What happens if it's not equilateral and it's not given to you, that you can't find the height, okay? This is a formula you can use. So if you are given two sides and the included angle, so it has to be side angle side, then you can use any of these formulas. 1/2, the product of the two sides, times the sine of the included angle. So if you're given side B, C, and then angle A, you would use the first one. If you're given side A, B, and the sine of and the angle C, you'd use the second one. If you're given side AC and angle B, then you use the third one. So it's 1/2 the product of the sides times the sine of the angle. And it looks like this. Find the area of the triangle, round to 2 decimal places. So A says given B is 52 meters and A is 90 meters and angle C is 102. So you should be given one of each letter. That's how you know it's side angle side. 2 lowercase, 1 uppercase. So this would be 1/2. I would use A, B, sine of angle C. So 1/2 52 times 90 times the sine of 102. So 0.5 times 52 times 90 times the sine of 102. And I get 2,288.87. Did it say what around to? 2 again. And this would be meters squared because it's area. But again, WebAssign won't even ask for the unit. B gives you A, B, and angle C again. So this is 1/2 A, B, sine of angle C. 1/2, 24, times 18, times the sine of 80 degrees. And then type it in. 0.5 times 20 times 18 times the sine of 80. Yeah, I typed 25. 0.5 times 24 times 18 times the sine of 80 is 212.72 yards squared. No. You don't have to, you don't even have to draw any. I think drawing helps you, but you definitely don't have to draw them. All right, so that's overall law of sines and the area, it's called oblique, the area of an oblique triangle. And then when we get a law of cosines, you're gonna learn formulas for law of cosines. There's no ambiguous case there, that's the good news. And then you're gonna learn one more area, and then that's what will get added onto the 7-1 and 7-2 and 7-3 test, okay? So question that they are, it's obviously not the same, right? But they are in the Pythagorean identity together. So you want to square both sides, but before you do that, you want to separate them out. So I move the secant on the other side. And I get tan of x equals root 3 plus secant of x. And then you square both sides. So tan squared x would equal, and I would FOIL this out. So it becomes 3 plus root 3 secant x plus root 3 secant x plus secant squared x. Or 3 plus 2 root 3 secant x plus secant squared x. So you don't want to like intertwine them any more than you, which is what would have happened if you squared both sides before you moved it. You want to separate them out and then square it. So then because I have a secant and a secant squared, I want to replace the tangent with the secant. So tan plus 1 squared plus 1 equals secant squared. So if I isolate tan, tan squared would equal secant squared minus 1. So that goes here. Secant squared x minus 1 equals 3 plus 2 root 3 secant x plus secant squared x. Then I want to group them. So subtract the secant squareds from both sides. And I get negative 1 equals 3 plus 2 root 3 secant x. Subtract the 3.
And you can do the AB thing with, I mean the A squared and A, right? Because there's a square root.
Right. Well, because and the squared cancels. So I think it's easier to do it that way.
Wouldn't you want to add the 1 so it equals 0?
Well, it doesn't matter. You only have to have it equal 0 if you're going to split and solve it. You could. I could move the 1 to the other side, but then you're just going to move the constant back over.
Then you just divide by 2.
Divide by 2 root 3. And I get secant x, you're welcome, is negative 2 over root 3, which means cosine is negative root 3 over 2.
Is there going to be one like that long in the quiz?
There might be one.
So
There's definitely one where you're going to have to square both sides, because then you have to check those. So there's definitely one like that. Are there going to, yeah, there's definitely going to be radicals because there's a lot of root 2s and root 3s.
No, I need it in the question.
With the expansion, I don't think so.
How many questions do you
7. Yeah, I'm going to give you the unit circle and the trig box. Yeah, you get this tomorrow. It's getting smaller, but it's still on there. Unit circle and trig box.
I'm blind.
Okay, bring a magnifying glass. All right, but wait, I'm not done, right? So then you gotta find where cosine's negative, right? So that happens at where it's negative would be 5 pi over 6. And it's negative in the third quadrant, 7 pi over 6. And then it depends on the instructions, right? If it said 0 to 2 pi, I'm done. If it doesn't say 0 to 2 pi, then I have to add 2n pi. But these are the ones you had to check. Like I think when you plugged it back in, this one didn't work, right? Yeah, one of them didn't work. If you square both sides, you have to check them. You literally plug it back in. Like I'd come back up to the top and I'd plug 5 pi over 6 into both those spots.
Are we gonna calculate tomorrow?
No,
So we have to do that?
it's all unit circle based. So then you'd go to 5 pi over 6. Yeah. You know how to do that.
Yeah.
Bye guys, have a great day.